Okay, welcome back. We're looking at the chain rule today. So before we can, a little bit of review just to reestablish some key concepts. When we look at a function in terms of x, we want to recognize that what we're being asked to do is basically input the x value into all these key spots of our function. So in this case, f at x, and x goes in here, and x goes in here. When we look then at something like f at -2, -2 fills those key spots, those key input locations. And if we take it one step further, we could theoretically, and we can, input an entire expression into those, or an entire function of its own, into those same key spots. So in this case, g at x is what we're going to input into the function. G at x happens to have the value root x in this example, and so root x fills in this input here, root x fills in this input here. Where that leads us, and I didn't necessarily mean for you to see this, but that's okay. If we look at the power rule for derivatives of functions, when I had something like, erase this here, f at x equals x to the exponent 3/2, where we know we end up is right here. The exponent is multiplied by the coefficient out front. In this case, the coefficient is 1, of course, so I have 3x out front. I subtract 1 from my exponent. 3/2 minus 1 is 1/2. And so this is my resulting derivative. Where it came from is, again, this middle term, f prime. This is just, again, another way to write derivatives down. And how we read this is the derivative of x to the 3/2 with respect to x, or in terms of x. So question becomes then basically, how does that affect a more complicated question that looks to be in a similar form, something like this? Hopefully you can see that this expression, I have this thing to the exponent 3/2. In this case, I have this thing to the exponent 3/2. And if I have an unknown value to the exponent 3/2, I should end up with, for my derivative, 3/2, the unknown expression to the 1/2. So certainly that has to hold, because again, I just have an unknown value here that I need to take the derivative of. So the first part of this, 3/2 multiplies by the coefficient out front. The term, the expression in the middle remains unchanged, and to the exponent 1/2. The difference now, of course, is I have this part right in here that I have yet to deal with in any way. I'm taking the derivatives of this entire expression, which means that I somehow have to take the derivative of this part of the expression that I haven't yet dealt with. And so how we do that, basically just continue the process. We're saying this part hasn't been dealt with yet, so let's deal with it. So we're going to multiply this first part by the derivative of the 3x squared plus 61x with respect to x again. And so what we end up with, the first part of the expression hasn't changed, the first part of our result hasn't changed, and then over here, 6x plus 61. Depending on what we have here, we're likely to finish. I suppose, again, always there could be the possibility that the expressions at this point are fairly nice and simple, in which case expanding them might make sense. For our purposes, this is how far we need to go the vast majority of the time. And so what we really did here was, starting with this larger expression, we took the derivative of the brackets with respect to 3. Sorry, we took the derivative of the entire term with respect to the brackets, and then we took the brackets with respect to x. So essentially we said, I don't really care what's in here for now. So I'm going to deal with this almost this way. Take the derivative of whatever's here. To do that, exponent again multiplies out front, subtract 1 from the exponent. And so whatever was in that spot there is ignored at the first step. The second step will be then let's deal with what's actually there in terms of x as well. And so again, in all of these cases, I'm not worried about what's in the brackets initially. I just know that I have to deal with some unknown value to exponent 3/2, which means I'm going to have 3/2 times that unknown value to the exponent 1/2. And then, oh yeah, I haven't yet dealt with that unknown, so let's deal with that unknown now, right over here, with respect to the value x. And then it turns out that what's under the boxes is 3x squared plus 61x. But regardless of what that was, this term would have just continued on through in all cases. Over here now, I need to reveal and find it. I need to take the derivative of that with respect to x. And of course, that's going to be the 6x plus 61. Okay, so this is essentially a missing step, or again, just a semi-explained step that was kind of squeezed in right at that spot there. In terms of another one with the quotient rule here, I'll go through it a little bit quicker this time. So quotient rule tells me to take the derivative of the numerator, leave the denominator alone, subtract numerator times derivative of the denominator, and again, all over the denominator squared. Okay, so that's just sort of how that works out. Now, the actual derivative of this part right here, if I were to do just that, I would take the derivative of 6x minus 1 to the 5th, or again, my unknown value in here, my unknown bracket, with respect to itself, and then I would deal with what the contents of the unknown bracket are with respect to x. Okay, so maybe even writing it that way makes more sense. That's what I have to deal with. Something to an exponent 5 versus itself, and then that's something with respect to the x. Just slide that off to the side. And now when I'm doing my g of x, or g prime of x, I'm going to have, in this first part, the unknown value to the exponent 5 means I will have 5 times that unknown value to the exponent 4. And then I have to deal with that unknown value with respect to x. Well, the unknown value is 6x minus 1, and so the derivative of 6x minus 1 is simply the 6. That's the derivative of this first part here. The second part here, the root, I have yet to deal with. Subtraction 6x minus 1 to the 5th, I have not yet dealt with. And then once again, the derivative over here. If I'm dealing with this, I have something to an exponent 1/2. And so I need to take the derivative of that something to the exponent 1/2. Oops, sorry. Versus the something. So I don't care what's in the brackets right now. I just know there's something there. I have to deal with the 1/2. And then I'll take the derivative of whatever was there with respect to x. So in this case, I have a 1/2. My exponent is 1/2 times, again, whatever is in the brackets. subtract 1 from 1/2, and I get an exponent of -1/2 being the result. And then I take the inside of the bracket, which happens to be, oh neat, x cubed plus 3, and take its derivative, leaving me with 3x squared. And all of that is divided by the square root of this squared is just x squared, sorry, x cubed plus 3. And this is looking pretty messy already. I guess I'll simplify it a little tiny bit. How much we simplify will be dependent somewhat on the individual questions. What's reasonable, what's not reasonable. In this case, I see I have a 5 times a 6 over here. It's 30. And I have 6x squared minus, sorry, 6x minus 1 to the 4th. And then root x cubed plus 3 minus, over here I have, I guess, 3 times 6x minus 1 to the 5th. Okay, so this is times the x squared. I guess I should have written 3x squared out front. It would be a little neater. Divide that by my denominator. I have a 2 here. And this is the denominator of just this one section. 2 root x cubed plus 3. And again, all of that over x cubed plus 3. Didn't think this through very well. I'm going to stop there. We can actually take this a fair bit further, and we probably would. I could factor out the 3 and the 30. I can factor out this expression here and this expression here. And then I can simplify the whole thing into a single fraction. We've actually done a fair number of questions that look similar to this when we were dealing with the first principles, so the manipulating of the algebra is not too bad. I'll write it out and send it in and post it on the solution part, but you don't need to watch me doing it. And so I'll stop there. There is a third example on this. We'll do more tomorrow. So I have a product rule example as well. And you can kind of read through it. Again, taking the derivative of the first part, leave the second part alone, leave the first part alone, take the derivative of the second part. Guess I'll go through it fairly quickly here. And then the chain rule says take this bracketed expression to the exponent 4 versus itself, and then take the bracketed expression compared to x. And this one will simplify a little bit more nicely, although you can see that it's relatively complex after the fact as well. What ends up happening in a lot of these questions, and it didn't in the one I did just a minute ago simply because of the roots going into the negatives, but you can see that I end up with x squared plus 3 expression, or terms with x squared plus 3 factors in both parts. I end up with 4x minus 5 as a factor in both parts. And so a lot of the expression will factor out to the front, and then the other part can be simplified relatively easily. The example I chose, like I said, not quite as nice, so I'll finish it up and then post it shortly.